Good morning to everybody. Myself, Dr. Maheswara Rao, Assistant Professor, Department of Civil Engineering, Institute of Aeronautical Engineering. Our course name is Fluid Mechanics and the topic is Cavitation. So before going to the course topic, we'll know what are these outcomes, course outcomes. So at the end of the course, our students should be able to define the fluid and its properties. That is the course outcome 1. So definition of the fluids and its properties, and surface tension and relations in different conditions. So all those will come under the course outcome 1. And Newton's law of viscosity, and the classification of fluids, and problems related to the Newton's law of viscosity. That is the course outcome 2. Here, course outcome 1 means definition of the fluid and properties. So different properties may be there. Newton's law of viscosity. Viscosity means resistance to flow. Then course outcome 3 is the student be able to employ a capillary principle to calculate the capillary rise or fall. So here capillary rise or fall means, so whenever you insert a small tube, small diameter tube in a liquid or fluid, okay, that liquid will rise or the liquid will fall compared to the top surface of the liquid, which is called a capillary rise or fall. So various advantages and practical applications are there for the capillary rise or fall. So course outcome 4 is the surface tension and their applications. So that means any liquid will have a tension at the surface, which is called the surface tension. You can know by means of this capillary tube. Then course outcome 5. So capillarity and compressibility. And course outcome 6 is the pipe flow. That means whenever fluid is flowing in a pipe, so it will have some friction between the pipe surface and the liquid. So that how this energy is decreased, lost because of the friction, those details will be there in the course outcome 6. Then if you come to the cavitation, what is the meaning of cavitation here? So as per the definition you can see here, so it is the formation and collapse of vapor fluid cavities, bubbles in a liquid when the local pressure falls below the vapor pressure. So you can observe here, vaporization, that means the liquid will be converted into gaseous state. So in a material from the liquid state to gaseous state, so which is called vaporization. That means here cavitation. Normally, if you want to convert the liquid into vapor, that means air form, liquid form to air form, normally we'll heat it, so that because of the temperature, after certain temperature, what will happen? The liquid, example water, it will be converted into gaseous form. Okay. Here, the similar thing is here cavitation. Okay. A formation, that means the bubbles, and the bubbles again they will collapse and again they will convert it into liquids. So here the thing is that cavitation, here bubbles are formed. Okay, the bubbles are vapor filled bubbles, cavities. Okay, without raising the temperature. So normally whenever the turbine is there, okay, submarine is there, pump is there, okay, there the temperature, there is no difference of temperature. Temperature is same, but even though temperature is same, the water will be converted into gaseous form, which is called here cavitation. Why this liquid form is converted into gaseous form without raising the temperature? So that is due to the pressure here. So local pressure. So that means if pressure is reduced, so that the outside pressure will become lower than the inside energy of the water, so that the water will be converted into gaseous form without raising the temperature. Here the matter is that without raising the temperature, the water will be converted into gaseous form. Okay, that gaseous form, again, if it is more pressure is there, then it will be broken and it will get back to the liquid material. So that is the definition for the cavitation. So cavitation means it is nothing but the formation of bubbles and returning and collapsing of bubbles and again forming into the liquid form. You can see here. So some experiment. If you take a beaker here, you are taken some liquid in this. So liquid means water, okay. So before boiling, that means we are not increasing the temperature. Both of these figures, we will not increase the temperature. Temperature is same. But in one first case, there are no bubbles here. But in the second case, you can see here, the bubbles are here. Okay. So these are the bubbles. So here, no bubbles are there. So because atmospheric pressure is there exerting in the beaker, so equal to energy in the water. So if whenever, by means of this tube, okay, by means of this tube, you are removing the air, that means pressure. So you are lowering the pressure inside that, so that water will be automatically converted into gaseous form. So you can observe here bubbles. So these are the bubbles here. So at low pressure, so water will get bubble form, gaseous form. So here key concepts are the cavitation, vapor pressure, pressure recovery. So what is vapor pressure here? Cavitation occurs when local pressure drops below the vapor pressure of the liquid. So you can see here. So here no bubbles are formed. So because you can see our definition here occurs when local pressure drops. So local pressure drops, then vapor pressure will go. So here this pressure is becoming less, top surface of this liquid, hence that means local pressure is dropped, hence this water form is becoming into a gaseous form, that means bubbles are formed, which is called here cavitation. And pressure recovery, after region of low pressure, if pressure rises, the vapor bubbles collapse, so potentially causing damage. So the thing is that why should we learn this cavitation? So here cavitation, why means the major thing is that damage. Okay. So whenever local pressure is dropped, this water will become into gaseous form. Okay. Then again, if it is traveling in a pipe or somewhere, whenever the high pressure exerts on this, so these bubbles will collapse. Okay. These bubbles will collapse and they will become into liquid form. So which causes the damage of the material. Okay. This is the reason we are studying this cavitation. So main thing is that damaging the material of pump, okay, propeller, all those things in turbines, submarines, everything. Effects of cavitation. So here you can see here surface pitting. So that means what is that? The bubble collapse near a solid surface can cause material erosion. So whenever these bubbles, after forming the bubbles, these bubbles are getting back into the liquid form by collapsing the bubbles. So while collapsing, it will have pitting action so that it hits the surface of the material, so that it may be iron or it may be any other material. That material will be eroded. So which is called here surface pitting. Another one is noise and vibration. Okay, cavitation can cause significant noise. So big noise will come in the pumps and turbines. Okay, pumps as well as turbines. What is the pump here? Pump is nothing but the taking of the water, bringing the water from bottom to top surface, top one. So that is called a pump. So it is normally, it occurs from bottom to top, traveling from one lower level to a higher level. So it is called pump. Whereas turbine, so turbine is reverse process. So turbine is there. So water is traveling from top to bottom through the turbine. So the turbines will work. So here, reverse process. This fan-like material here, okay, that rotates, so which causes the pumping of water, rising of water to higher levels. Here, by using the water, here a fan-like will rotate so that energy will be created, electricity will be created. So both of these will get this cavitation. Okay, at low pressures, okay, at the propeller, impeller, okay. So propeller and impeller, two things will be there. Okay, impeller means it is having pumps, and propeller means in the turbines. Whenever low pressure occurs at the impeller or propeller, so immediately bubbles will form. So after getting a high pressure, these bubbles will collapse and make noise and also erode the material of this impeller or a propeller. Practical applications. Where will utilize this? Cavitation. Okay. So here pumps and turbines. You can see the pumps and turbines in applications. So what is here? Severely damage the components. So whatever the components in the turbines or pumps, these components will be severely damaged because of this cavitation. Okay. So what will happen if the components are damaged? Automatically lifespan will be reduced, efficiency is reduced. What is the meaning of efficiency? So whatever the energy we are giving, input, output must be equal to the input. So if output is less, then efficiency, we can tell it as a low efficiency. Okay. So lifespan means usage of that particular thing. So that is a lifespan of that pump or turbine. Then propellers. The cavitation affects the performance and durability of ship. I already told you propeller here. So if any turbine is there, turbine means here submarine, example submarine. So here some fan will be there. Okay. So this one will rotate. So that this submarine will move. Okay. So while moving this, so at one side of this propeller, very low pressure will be formed, because if the water is flowing, pushing like this, so if the fan is this one, so here high pressure will be there for the liquid. At the same time here, low pressure will be there. So whatever the liquid here, okay, if it is pumping in this direction, okay, this here bubbles will form. That means cavitation will occur. And whenever coming that side, so that means high pressure will come, so that pitting action will take place. So noise will become, and also erosion of material will occur there. We'll see the figures of the propellers also. So compressibility and elasticity. See, large values of bulk modulus indicate incompressibility. Here, compressibility, that means if you can make the volume into smaller one, or if you make the, that is called compressibility. So, okay, if you take this much volume, if you can make this much, so by applying some load on this, some pressure, so if it is reduced the volume, okay, then that is called compressibility. So if you cannot do that, that is called incompressibility. Okay. So large values of bulk modulus indicate incompressibility. So if any material is having highest bulk modulus, then we can treat them it as incompressible, because already it is high bulk modulus, so that it cannot compress. So that's why large values of bulk modulus, okay, shows that that material is incompressible. Then one next point is that incompressibility indicates large pressures are needed. Large pressures are needed to compress. So already bulk modulus is high. If you want to compress it, then very large pressures are required to compress it. So that it means. So you can see this is a submarine. Okay, this is a impeller rotating. So you can see here bubbles. So these are the formation of bubbles. Okay, you can see here, this is also, you can see in this figure. Here the water is flowing in this direction, so here pressure will be more, so nothing will happen. But whenever it is coming like here, what will happen here? Pressure will become very less. So that's why here cavitation bubbles are formed. So pressure dropping will occur here. So bubbles will be formed. Okay. Here expansion of the bubbles will occur. So here bubbles collapse, releasing intense energy. So after reaching certain pressure, higher pressure. So at lower pressure, you can observe here the formation of the bubbles, increasing the bubbles, and whenever you are reaching the high energy, high pressure, these bubbles will be, you can see here, collapsing of the bubbles, so that it hits the surface of the material, so that damaging of that particular material will happen. So you can see this impeller, you can see this is the damage due to this cavitation. So here water is flowing like this, that's why this side will be damage will occur. So okay, this is a impeller. So it is used in the pumps. So this is a impeller. Okay, so that is used in the pumps. You can observe here so much damage in the impeller because of this cavitation. So what will happen if such damage is there? One thing is that efficiency will be reduced and lifespan also reduced. So references are theory of applications of fluid mechanics, okay, Subramaniam, Tata McGrails. Another one is Modi and Seth, hydraulics and fluid mechanics, Stan Bluehouse 2002. So if you review what you learned today is that okay, first definition you have told, that is nothing but the formation and collapse of the vapor filled bubbles. So first bubbles will be formed and they will be collapsed. That is called the cavitation. Whenever the local pressure is false, so bubbles will be formed. Whenever the local pressure is increased, then the bubbles will be collapsed. So this is the experiment. You can see it. Okay. So before dropping the pressure was the first figure. Okay. So after lowering the pressure, so at lower pressure, bubbles are formed without raising the temperature at constant temperature. Okay. So this is the definition, same thing. Okay. Then damage will occur due to cavitation. So this cavitation effects will be pitting action, so that erosion of material will take place and significant noise also will come. So they will damage the components of these pumps and turbines, submarines, like that. So practical applications, pumps and turbines, so they will damage, the cavitation will severely damage the components, so that efficiency and lifespan will be reduced. So propeller, so the ship is having propeller in the submarine, so propellers also will get to be damaged due to the cavitation. Compressibility, so bulk modulus is the thing that, so highest bulk modulus you can take it as a incompressible. So if you want to compress the highest bulk modulus, you have to apply the highest very large pressures, then only it will become a compressibility. So this is the submarine, so bubble formation. And so this is also a tapered pipe. Okay, so convergence and divergence pipe. So here it is reduced the diameter and increase the diameter. Whenever reduce the diameters, then so it will happen, more pressure will be there. After that, here we will get low pressure because of pressure drop. So cavitation, bubbles are formed and they will be collapsed whenever reaching the highest pressure. So that's why this material, pipe material, also damaged because of the cavitation, because the collapsing of the air bubbles. So these are the pictures of damaging of the impeller. Okay, this is a propeller which is used in the pumps. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.